Greetings. This video is a basic guide on how to use Rust and some syntax and some concepts that are also used in Rust. Why Rust? There are many other languages, low level and fast. These other languages though are missing one key feature of Rust: safety. Safety is the main reason why Rust is so popular. For example, consider a piece of C code that creates a dangling pointer. The compiler would report nothing is wrong, but when running the program, and there may be lots of time delays between starting the compilation process and running the time delay. When running the program, there will be an error relating to the dangling pointer. If this could just be fixed in the compilation process, so much time could be saved. This is what Rust does. Rust moves many errors that you get in runtime to the compilation process, which makes it much easier which makes it much easier on the edit compile run cycle. Most of the time, the first thing you will build with any programming language is a simple hello world app. That is what this section is about. To create a new Rust app, run cargo init. This will create a new Rust app in the current directory. So now as you can see here, we have a file named source main.rs, a git ignore, and a cargo.toml. We'll see more about the cargo.toml later. But for now, pay attention to the main.rs file. As seen here, we have this one instruction: println exclamation mark, and then some brackets, and then hello world. The println is what's known as a macro. Right now, that does not need to be worried about. All we need to know is that this prints to the standard output. If we run it using cargo run, it will compile, build, and then we'll run the executable. As you can see here, it prints hello world. Now let's break down this. Fn main means to create a new function named main. As you can see here, fn main does not return anything. It does not take any arguments at all. Arguments would be declared as like this. This is how an argument would be declared. However, main typically takes no arguments and typically has no return value. So right now, this line will simply be fn main with two brackets. Curly brackets are also included, and then in here we have a function called the println macro, which prints hello world. The syntax is fairly similar to other languages such as C, but differs in a few areas. Variables are a key part of any programming language. To make one in Rust, simply use the let keyword. This right here makes binds x to 10, which means that we can now print it. To print a variable, unlike other languages, we cannot simply do this. This, as we can see, creates an error. Format argument must be a string literal. Rust also includes very helpful error messages. As we can see here, it says that we require a string literal. The string literal takes a place where a bracket is and then puts the value of whatever is in the succeeding arguments after the string into the brackets. Say we declared a couple of variables such as let x, and then let y, and then let z, So now the order it will print in is the order we pass them in after the string literal. Now if we run this, we can see 10, 12, 13 in the same order that you passed in. There are also mutable variables. By default, this x cannot be assigned a new value to. Say we wanted to reassign it to 12. Let us just add places to print the x both times, before and after the change. Now let's run this program. As you can see, cannot assign twice to immutable variable x. Immutable means that this value cannot be changed. This will always be x. But what if we really need this variable to change? To do that, add the mut keyword. This tells Rust that this is mutable. It should be able to change. And in fact, we will change it here. And now as we can see, first 10 is printed before the change, and afterwards 12 is printed. There are many data types in Rust. The first basic one, which we've already used before, is I32. This is also the syntax for saying a variable should be a specific type. And I32 is a 32-bit integer. It goes from I8 and then continues on to I32. There is also U32, which is simply unsigned instead of signed. There is also the two special ones, I size and U size. What I size and U size are the platform specific versions. That is, if you are running on a 64-bit computer, I size will be a 64-bit integer and U size will also be a 64-bit integer. I size and U size are mostly used for memory addresses in Rust, but that is not something that we need to worry about now. There are other data types too. There is the array data type. This is a simple data type that just stores a specified number of values. As you can see here, we have an array of 12 numbers. I mean 3 numbers, with each of those 3 numbers being 12. There's also the tuple type. A tuple is sort of like an array. However, it has specified data types for each of its fields and can have different data types for each field. Say we wanted the first one to be a number and the second one to be a string. This will make it such that x is now a tuple with 12 being the first variable and string being the second variable. To access them, we can index with this sequence. X dot 0 will get us 12 and x dot 1 will get a string. There is also the vector. A vector is much like an array. It has one data type, however it does not have a fixed size. If we need to, we can add more elements to it. However, to do so, we must make the variable the vector is assigned to mutable. As said before, you cannot change a variable unless the mutable keyword is given. So let's say we have an array of 3 numbers. You can use x.append, actually x.push to append 12. Now if we check afterward, sorry, now if we check the value of x afterward, it will in fact have 4 12s instead of simply 2 12s. Functions are another integral part of many programming languages. As we've seen before, the entry point for all Rust programs is the main function. This main function is the function that all Rust programs will start. All the code that will be executed will be stored here. However, to split all the code up, we can also define separate functions for ourselves. As we can see here, you can use fn to create a new function. Now let's say we want to create an add to function. It takes one argument and returns one argument. This form right now makes it such that it takes no arguments and returns nothing at all. These functions like these typically have some sort of side effect, otherwise they would be completely useless. Now let's take a parameter number to add to 2, and let's say we need it to be an I32, as essentially it should be a number. Now to mark the return type, we use this along with I32. This is simply a dash with the right facing arrow and then the type that we are going to return. So now we can simply return number to add 2 to plus 2. We can either use the return keyword or we can simply just use or we can simply do this. The last value that is executed without semicolons will be returned from the function. If we add a semicolon, Rust gives us an error. However, if we remove the semicolon, we are telling Rust that we should take this number, add 2 to it, and then return it. This means we can now run this function. This is how the function will work. We can now check the value and see if it is the same as we want it to be. As we can see, 2 plus 1 is equal to 3. Our function has worked and we have successfully created a new function. In Rust, the classical type of loop is a for loop. To demonstrate this, we can create a function that reverses a vector. First we need to create the function and to signify that it takes an input of a vector, we can use this syntax. This essentially means that it's receiving a function. This is essentially means that it's receiving a vector with the type of I32. So it's receiving a vector, but inside are I32s, and it also needs to return a vector with I32s, as we are simply reversing the array and returning it. So this is how the classic for loop goes. For I in 0, right here we can use the variable I. This is in Rust what's known as a range. This range counts from 0 up to 99. We can demonstrate this like this. Actually, first we'll reverse the array. So the technique we're going to be using here is to simply loop over all of the elements in the vector and then insert them backwards in the reversed vector. So now we need to loop as a so we need to loop from the length of the vector from 1 to the length of the vector plus 1. The reason we have the 1 plus 1, the 1 and the plus 1 is due to the fact that to get the reverse element, we can subtract the total length by the index. So we'll get the opposite element. That is our that is opposite around around the central element. We can then do this reverse vector push, and then the value is and then index the vector dot length minus the index. So let's take a moment to just step through this code. First, we signify to us that this takes one vector with I32 values and returns one vector with I32 values, and then we create a variable which is simply a vector named reversed vec using the vec macro. And then we loop over and we start at 1. So reversed vector push vector len, let's say it's 3. 3 minus 1 gives us 2. So then we get the second element. While indexing, we get the last element as we start with 0 and then end with the length minus 1. So this gets the last element, and then 2 minus this will get the second to last element, and then 3 minus this will get the first element. And as we push them in reverse order, the reversed vec will now contain everything in reverse. Let's try this. So we need to return the reversed vec, and as I said before, you can either use return with semicolon, or you can simply omit the semicolon and have the value returned implicitly. This is the most common form. Let's call this function. So then we can supply the vector, say 15, 16, 18, 18, and we can try printing it. Now see here, this is one of the things that you might encounter when trying to print something. As you can see, the trait as a standard /fmt set display. Now if you don't know what that means, essentially all it means is that Rust doesn't know how to print this to the screen. Therefore, we can use this syntax. This means to simply print it. Simply print the representation. As you can see, it has printed the array. We can also use this. This means to pretty print, and it prints it in a more viewable format. Now that we have made a reverse function, what if we wanted the user to supply a vector here, and instead of returning the vector, we can push all of the elements there instead. The vector would have to be empty, but and then that mean which then and then we can start pushing all the elements to that. Let's try this. Let's try a very simple code like this. Then we can create a variable. It has to be mutable. Reversed vec is equal to another empty vector. Now what if we add vec2 to the vec, and say this can just be again a vec of I32 since we are pushing that. Remove the return, and then we can also remove this line of code and this line of code. We can then, instead of pushing to reverse vec, we can push to vec2. As you can see here, this is different. This is also a different error. Rust does not know what you are going to put in the vector. It cannot see that we are pushing an I32 explicitly here, and so therefore it does not know. We can help it by doing two things. We can do this, which is essentially saying Rust that this is a vector I32, or we can try this one. Reversed vec, which means that Rust will be able to infer that this is now a vector. Let's try this now. Let's see if it reverses. Forgot to save. So now we can see this. Cannot borrow vec2 as mutable as it is not declared as mutable. Essentially, what Rust is saying that this reversed vector, we cannot use it even though we've declared it as mut. When we pass it in, say we pass this in, we now cannot use it again. The reversed vector is now immutable to this function, because we have never said that we need it to be mutable, so it will be immutable. So now this is what references are for. We can use the ampersand syntax to create a pointer. This pointer points to the vector. So when we come here, we can use all of the standard functions. And also we need to say that this function takes a pointer. And now the vector will be given a the reverse function will be given a pointer. It can use that pointer, but we need to do something a bit more for this. For reversed vector, we also do need to take a vector. We can also change the type here, but because we need to be able to add things to the vector too, we need to mark it as we need to mark it with an ampersand and mut after it. This declares it is a mutable reference, and through that reference we can change the original value too. So now if we try it, we can see that it does not change. But why? We checked everything. If we take a mutable reference, though, only the reference will be changed. To push it, we need to get to the original piece of data. Also, dereferencing takes place like this. So first, dereferencing takes place in a very strange order. So first we need to do this. So we can dereference the vector, and it's still not allowing us. Why? Reverse vector is empty, and everything is correct. So now we dereference that. This. Let's try stepping through this code and seeing what Rust thinks of it. So we push. Actually, this should not be necessary. Oh wait, we're printing the wrong vector. So this should. It's most likely yes. As you can see here, we have pushed. The star syntax was actually not necessary. But what it allows you to do is get what lies at the pointer. Instead of having a pointer, if you need the piece of original data, say this is simply a pointer to vec. What if you need vec itself? Then you can run star, then you can use the star operator, also known as a dereferencing operator, which is the operation opposite of referencing. This means that it will get the piece of data which lies at vec, and it will give you this vector instead of simply a pointer. So these are all the pieces of information you need to start writing Rust code. There are some more things you might need to take an in-depth look at, such as the ownership system and lifetimes. These two make up the main part of Rust safety system. Consider reading the Rust book. This video was not meant to be a primer on the concepts of Rust, rather a guide to the syntax of Rust. To accompany this video, you can also try watching the Rust book. The Rust book is written by the people who made the Rust compiler, and so is very accurate and contains lots of info. Thank you.